Hello students, how are you? Welcome to Applied Mathematics 1 audio video presentation. My name is Mr. Salamariam. Please stay home, stay safe. This module helps you to apply different type of mathematical equations to solve problems in your field of study and as well as in your daily lives, to develop linear problem-solving techniques, to develop ability to formulate a mathematical statement precisely, organize and manipulate large amount of data, to determine and analyze the shape of graphs, to determine the exact length of power cable needed to connect two substations which are miles away to each other. Learning Unit 1 Vector. Outline. Definition of points in n space. Vector in a plane and their geometrical interpretation. Scalar product, orthogonal projection and directions cosine. The vector product. Application of vector on area and volume. Finally, lines and planes. At the end of this chapter, you should be able to list the property of vectors, both algebraic and geometric form. List property of scalar product and vector product. Find the area of a parallelogram generated by two vectors. Find the volume of a parallelepiped generated by three vectors. As introduction, physical quantity that can be divided into two, a vector quantity and a scalar quantity. A physical quantity that possesses both magnitude and direction is known as vector. For instance, force, displacement, velocity, acceleration, and so on. A scalar quantity is the quantity that possesses only magnitude. For instance, mass, area, density, volume, and so on. Before to define a vector, let's see the definition of points in n space. For the point x in n-dimensional space represented by n tuple of real number, x1, x2 up to xn, the number x1, x2, xn are called the coordinate of x. In particular, when the point n which is equal to 1, the point represent in a number line. This number line have two parts, a positive part and a negative part. Based on the values of x, the point it is plot either in the right direction when the point have a positive value, or it is plot in the left direction when the point have a negative value. When the point it is contain two coordinates, n which is equal to 2, then represent in xy plane or two-dimensional space. The coordinates the point it is contain three coordinates, then represent in three-dimensional space. X, Y, Z. X is the first coordinate, Y the second coordinate, and Z the third coordinate. Example, let A and B are a points in two-dimensional space with coordinate 1, 2, and -3, 4. Then find the coordinate of A plus B, A minus B, B minus A, and -2A. A plus B, the solution. A plus B, to find the coordinate of A plus B directly to add the first coordinate of A with coordinate of B and the second coordinate of A with the second coordinate of B. Then equal to 1, 2 plus minus 3, 4. Then the first component of A plus B is 1 minus 3. The second component of B is 2 plus 4. Their coordinates are minus 2 and 6. A minus B, to find the coordinate of A minus B, the same ways in A. Simply subtract the first components of A with first components of B, and second components of A with second components of B. Then the result is 4 and minus 2. Using the same ways to find the components of B minus A. Now let's see the solution of scalar product of A point. To find the scalar product of A point, multiply each component of A point by a constant number. Then to find the component of minus 2 times A equal to minus 2 times 1, 2, which is minus 2 times 1, minus 2 times 2. The result is minus 2 minus 4. Based on this example, is A minus B equal to B minus A? Justify your answer. The second example, let X and Y be a point represent in 4-dimensional space. Then find 2x plus y and x minus 1 over 2 times y. Solution, 2x plus y. To find the component of 2x plus y, first find the components of 2x, scalar multiplication of a point, then add this result with the components of y. Finally, we have the components 4, 4, 0, 2. Activity. This is an activity, then try this activity by yourself. 1.2 vector in a plane and their geometrical interpretation. Directed line segment with the initial point at A and terminal point B is a vector and denoted it by AB. This one is a line segment with initial point A and terminal point B. Therefore, this vector is represented by AB. The length of the vector is known as the magnitude and represented by the norm, or which is the magnitude of AB. The vectors that have the same initial point and terminal point, which means the vector AA has a zero length, which is called a zero or null vector and denoted by this one. Two vectors, the vector AB and the vector CD, are to be equivalent if they have the same magnitude and direction. In the definition of equality of vector, does not require that the vector have the same initial point and terminal point. Only it is to check they have the same magnitude and direction. Example, sketch the vector with their initial point at the origin and terminal point 2, 3, minus 5, 5 plus 3j and 6j. Let's see the solution of the first one. To plot a point, the point 2, 3, the given point is 2-dimensional space. It has 2 coordinates, so it is represented in 2-dimensional space. Then to plot this point in plane, first it is to draw a horizontal axis and a vertical axis. Commonly the horizontal line is known as x-axis and the vertical line is known as y-axis. One is perpendicular to the other one. Then divide each axis by equal units, commonly which is divided by a single unit. Then divide x-axis by a single unit, and the same thing is divide y-axis by equal unit. Then measure 2 units in the x-axis, 2 units in the x-axis, and 3 units in the y-axis. Then find the point of the coordinate point 2, 3. Draw a line which is parallel to the y-axis at a point 2, and draw a line which is parallel to the x-axis at a point 3. Then the intersection point is the coordinate point of the 2, 3. Then the vector represented by line segment, it have initial point and terminal point. So the initial point is at the origin, which means the coordinate 0, 0. Then draw a line segment from at the origin, the coordinate 0, 0 to the terminal point, which is the coordinate 2, 3. Therefore, this one is a vector with initial point at the origin and terminal point at 2, 3. In the same ways, try see the solution of B and C. Second example, find the components of the vector and sketch the equivalent vector with its initial point at the origin. The first example, it is given the coordinate point, the point in two-dimensional space with a line segment from 1, 5 to 4, 1. Then to find the component vector, simply it is to subtract from terminal point to initial point. The terminal point of this line segment is 4, 1 and initial point is 1, 5. Then the components of the vector is 4 minus 1 and the second component is 1, 5. Then we have the component 3 minus 4. The second example, the points are represented in three-dimensional space. Then their initial point is 0, 0, 4 and their terminal point is 2, 3, 0. Then to find the component vector of this representation is subtract from terminal point to initial point. Then their coordinates are 2, 3 and minus 4. The third one, if P, Q, R and S are a point in two-dimensional space, then let's check that these two vectors are equivalent. QP, which is equal to SR. By the definition of equality of vector, two vectors is said to be equivalent if they have the same magnitude and direction, or the corresponding entry are equal. That vector is said to be equivalent. Now let's check the components of QP equivalent to the components of SR. Then first find their components. To find the components of the vector QP, simply subtract the points from terminal point to initial point, P minus Q. Then we have the result 2, 3. 2, 3 are the coordinates of a vector QP. The same ways, find the coordinate point of SR, subtract from a points from terminal point R to initial point S. Then their coordinate points are 2, 3. Based on these two results, the coordinates are equivalent. Therefore, these two vectors satisfy the condition of equality of vector. This is an activity. Try this activity by yourself. This is a definition of the sum, difference, and scalar multiplication of a vector. Let A and B a vector in two-dimensional space with their coordinates A1, A2, and B1, B2. And T be any real number. Then the sum of a vector A plus B, which is equal to A1 plus B1, comma, A2 plus B2. The difference A minus B, which is equal to a1 minus b, comma a2 minus b2. A scalar multiple Ta multiply each component of a point A by constant number t, then we have the component Ta1 and Ta2. Where t is an element of a real number, commonly which is non-zero real number, either to have a positive value or which is a negative value. If t have a positive value, then the scalar multiple of a point t times a is a vector in the direction of a. When t have a negative value, then ta is in opposite direction of a. This one is geometrical representation of the sum of the vector and scalar multiplication of a vector. This one is a vector A and this one is a vector V. The initial point of a vector B is the same as the terminal point of a vector A. Then the vector A plus B is exist with initial point the same as A and their terminal point with the terminal point of B. This one is the scalar product of a vector. If t have a positive value, therefore a vector A and a vector t is in the same direction. When t is a negative value, the vector A and the vector t A in opposite direction. One is opposite direction of the other one. Definition of parallel vector. A and B are said to be parallel vector if A which is equal to t times B or B which is equal to t times A for some real number t, which means two vectors it is said to be parallel if one can be expressed as the scalar product of the other one, any constant multiplication, then the vector it is said to be a parallel vector. This is an activity. Try this activity by yourself. Let A, B, and C be a vector in n-dimensional space, and let M and N be any real number, commonly which is non-zero real number. Then the commutativity A plus B which is equal to B plus A. Means operation addition to satisfy a commutative property. Associativity M times NA which is equal to M times N times A. A plus B plus C equal A plus B plus C. Distributive M times A plus B which is equal to MA plus MB. M plus N times A which is equal to MA plus NB. 0 times A equal to 0. A is a vector, therefore the result is a 0 vector. A plus 0 equal A. This is an activity. Try this activity by yourself. So